Okay, this video I'm going to cover question 15 and 16. It is easy question. If you are having problem, it means that your revision is not thorough. So here what you need to do for question 15 is that you should know that spring balance is an instrument to measure the weight. And you should know that the formula to calculate the weight is mass times gravity. So here from the diagram you can see that I have a spring balance showing a reading of 18 when the mass is 2 kg. So from this, you can actually work out what is the gravitational strength, and you can compare over here. Yeah. So once you do that, you should be able to find the answer. For question 16, it is a classic example to check whether you understand density. So if you are very solid in your content knowledge, you should know that your density, okay, is independent of how you cut things. It is a unique property. So no matter how you cut, the density will remain the same. If you want to know how it is proven, I can give you a short explanation. So let's say the original big piece of material, this big piece of material, let's say it has a mass of 30 kg and volume of 30 kg. So down here, it is just some dummy value that I have created, okay? From this, I would know that actually this material, every 1 kg is 1 cm cube, okay? So what I'm going to do is that I'm going to cut the thing so that this is 2:1. So this means that the volume of my X most likely will be 20 cm cube, and my volume for Y will be what remains, 10 cm cube. And since I've already worked out that each cm cube is going to be 1 kg, then you can see that the mass of X and the mass of Y is going to be 20 kg and 10 kg respectively. Once you know that, you can actually work out the density of X, which will give you 1, density of Y, which will also give you 1. So actually, no matter how you cut the density, you will get back the same density. Density only change when you are changing the state or when you are heating or cooling, because there's expansion, but the mass is the same. Okay, I'm going to push on a little bit to page 8 so that there's less number of videos to upload. Okay, for your question 17. For question number 17, it is actually quite straightforward. You are asked to calculate the density, so you should know that density is equals to mass over volume. Those of you who have a very small memory capacity, this is how I remember the formula. Okay, so this is M and this is V. Okay, so to find the M, you can find the M directly over here. To find volume, you will need this, because you can see that after you add in the plastic material, the water level actually increased by a certain volume. So actually the amount of water that was displaced must be equals to the volume occupied by the submerged plastic material. So that's how you approach this. Question 18, what you need to know is that you should know that when you have a small density, you tend to float. In fact, the density must be lower than the medium. So if you do that, you can actually rank it that R is having the smallest density, Q will be the highest. So a descending order, meaning that the density will get lesser and lesser. So I should have R at the back, Q at the front. Answer is B. Okay, for your Q19, it is about moment. So you should know that your moment is given by the force multiplied by the perpendicular D. And this perpendicular D is between the line of action of the force until it is connected to the pivot. So let me use this opportunity to recap with you. Line of action of a force simply refer to extending the vector. So this is the line of action of F3. F3 is here. So perpendicular distance will be from the pivot to the line of action of force 3. So just by looking at this example, you can see that F3 will have a certain moment because it will be F3 multiplied by this perpendicular distance. So the only way for something not to have a moment, it is when your line of action of the force cut the pivot. When this happens, the line of action is on the pivot, and so your D is 0. So if you look at this closely, there are actually two forces whereby the line of action actually cuts the pivot. Okay, you go and figure out. So like I said, I am running out of space to upload my YouTube video, so please like